Okay, I'm going to do my best to explain confidence intervals to you. And I promise the videos will get better. It's going to take me a little bit to figure out how to do this the best way. So first of all, the reason we have confidence intervals is so that we can determine if stuff that advertisers or consumer reports, if those are actually accurate. So first of all, if we don't have any other data but the mean is the best thing we could use to approximate any other piece of data. So on that first example, that's why the best approximation would be 82%. And then the standard error of the estimator is just the same as the standard deviation of the sample means. Now, what we're going to use to create confidence intervals is margin of error. Margin of error is kind of like the wiggle room. It's how much you can vary from the mean. So the formula for this is z sub c times the standard deviation of the population over the square root of n. And if you don't know the standard deviation, you are allowed to use the sample standard deviation as long as n is greater than or equal to 30. Do you remember that 30 from the last chapter? It's going to be a very important number. So z sub c is the value on the standard normal curve with the area c in between the two critical values. So here, let's say the two critical values, which are symmetric to 0, are negative z sub 1 and positive z sub 1. If you are given alpha, which is the confidence level, then the area in between those two is considered alpha. So if alpha was 80%, meaning you wanted to be 80% confident, if you subtracted that from 1 and then divided by 2, you would have that the area of each of these tails is 10%. So how do we find the critical value, the z value, the z sub alpha or z sub c, same difference. So z, the way you would calculate it is, if we knew the area of this to be 10%, you would calculate it by taking the absolute value, and that's just to make it positive, of the inverse norm of the area to the left. These things are called critical values, and they are always positive. So for example, if we wanted to find this first one, the z, or the critical value for an 80% confidence level, what you would do on your calculator is take the inverse norm of, if it's 80%, you would take 1 minus 80%, which is 20%, and divide it by 2, which is 10%. And written as a decimal would be 0.1. And then take the absolute value of that number, and you would get positive 1.28. Now, typically, when you're doing confidence intervals, you would want to be 85, 90, 95, or 99% confident. We don't typically say, oh, I want to be 87% confident. So those are ones that you definitely will want to know. Maybe highlight those. So here's an example. Pause it and read through. Okay, now the confidence interval, how we create it is we take the sample mean and we subtract the margin of error, and we take the sample mean and add the margin of error. And that gives us an interval between a lower bound and an upper bound. And again, that margin of error is what I like to call wiggle room. So you need this piece of information from the problem. N is the sample size, X bar is the sample mean, S is the standard deviation of the sample, which is just an S, but since N is over 30, 100 is greater than 30, then you can use that in place of the sigma in the formula. And again, remember the formula, z sub c times the standard deviation over the square root of n. And then it tells us to do this for alpha, the confidence level being 95%, which means the critical value we should use is 1.96. So to calculate this, margin of error, we do 1.96 times 3 over the square root of 100, and we get the margin of error. We're going to add and subtract that to the mean, and it gives us this lower bound and this upper bound. This is considered the confidence interval. What that means is if we repeated this over and over, with many, many, many samples of 100, 95% of the time, the population mean would fall in between those two numbers. Now, we're also going to do that to 99% confidence interval. The only difference is the margin of error. We're going to have a different critical value because for 99%, we have a different z-score. So when we use that number, because it's bigger, it's going to make the margin of error bigger, which when we add and subtract that to the mean is going to give us a wider confidence interval. So we have a little bit more wiggle room there. So again, the way the confidence level affects the confidence interval is the more confident you need to be, the more wiggle room you need to have, which means you have to have wider intervals. Now, this next part is just showing you how we would solve for n, but essentially you need this formula to solve for minimum sample size. The critical value times the standard deviation over the desired margin of error, quantity squared. And you're always going to round that number up because this is a minimum. So for this example, take a minute to read it. Okay, what you're going to do, you're going to plug in the z sub c, and for 95% it's 1.96 times the standard deviation over the desired margin of error, which it says is 1,000, and then quantity squared. That gives you this number, but then you round up to 554 people. Okay, here's one last example. Again, you want to get the information n, x bar, and s, and you need the critical values for 90 and 95%. So I found two different margin of errors. Notice the margin of error is larger for the larger confidence interval, and then we add and subtract those to the mean. And notice again, the 90% confidence interval is more narrow, meaning we have a little bit more wiggle room, almost $3 more wiggle room in the 95%, because we'd have to have more wiggle room if we need to be more confident. Now, the rest of these problems, 1 through 7, is your homework. Good luck.